You know the SR-71 is a fast aircraft. You can tell by its design characteristics, designed for speed. It's the fastest aircraft ever built. There are rocket planes that went faster, but as far as a pure aircraft, pure airplane, this is the fastest one ever built. And what comes with that high speed, at Mach 3, 2,000 mile per hour speed, is heat. You're actually compressing air molecules on the skin of the aircraft, so it heats up. Just like a bicycle pump gets hot when you compress the air repeatedly, this airplane gets extremely hot. In fact, this close to my head was about 600 degrees when flying at altitude and speed. So the whole machine is extremely hot, up to 1,000 degrees near the engine section. And we're going to sustain that for an hour, hour and a half. So the aircraft is very, very hot. And remarkably, the cold fuel that we took on from the tanker is actually a heat sink. It's keeping that heat from overwhelming the electronic components, the hydraulic systems, and a number of systems on board that are subject to being influenced by that high heat. It's being moderated by the cold fuel that helps keep the airplane cool. Unfortunately, as you get close to the end of a long, high-speed run, the fuel is all but used up. And now that heat can become a real factor and manifest itself in a number of problems that you have to deal with. The aircraft actually gets longer because of that high heat. It'll grow about 6 or 7 inches in flight. So all the parts of the aircraft were designed with that in mind. Because of that high heat, we couldn't have a normal fuel bladder. It would leak. It couldn't sustain the heat. So the titanium skin of the aircraft is basically the fuel cell. In order to allow for that expansion at high speed and temperatures, there was a lot of tolerance built in between the parts for ground temperatures. That's why you see fuel pooling underneath a Blackbird on the ground. Any normal aircraft, if you saw fuel pooling on the ground, people would be running away from it. But this had a very special fuel that was designed for our purpose, JP7, very high flash point. You could throw a lit match in it and it would just go out. So it took a lot to start to burn that fuel. You saw fuel draining beneath the aircraft when maintenance crews were working on it and they had to refuel the aircraft, get it up to fully fueled and bring it down to a lower fuel state. The fuel would be spraying out the top like garden hoses and draining out the bottom like a rain shower. The maintenance crews would have to wear ponchos and respirators to work underneath the aircraft while they're being drenched in fuel. Very, very unusual operation in that sense.